Welcome back to episode 2 of definite integration. In this episode, I am going to help you to solve the definite integration problem in which substitution method is involved. Example 1. Evaluate integration 1 to 2, 2x into x square plus 1 with respect to x. Solution. First of all, let I equals to integration 1 to 2, 2x x square plus 1 with respect to x. Let x square plus 1 equals to t, because derivative of x square is 2x, differentiating with respect to x. So differentiation of x square plus 1 with respect to x equals to dt by dx. So derivative of x square is 2x equals to dt by dx. Therefore 2x dx equals to dt. So step 1 is over. Call it as a 1, call it as a 2, and call it as a 3. After that, we have to change the limits. In definite integration, whenever we go for substitution method, we have to change the limits. So here is a x and here is a t, and t equals to x square plus 1, and the limits of x are 1 and 2. So here in place of x write down 1, so 1 square plus 1 equals to 2, and here is 2 square plus 1, that is equals to 5. Therefore the new limit, the old limit are 1 to 2, we don't write those limits, we write the new limits, that is 2 to 5, and here is the 2x dx replaced by dt, and x square plus 1 is replaced by t. So integration of t is nothing but t square by 2, and here the limits are 2 to 5. Applying the limit, before that take 1 by 2 common, after that applying the limit, that is t square, here 2 to 5, so 1 by 2. Now applying the limit, 5 square minus 2 square, so that is equals to 1 upon 2, 25 minus 4 equals to 21 upon 2. This is required final result. Example 2. Evaluate integration 4 to 9 root x plus 1 whole square upon 2 root x. Here let root x plus 1 equals to t. Why? Because root x derivative is 1 upon 2 root x. Therefore I selected root x plus 1 equals to t, because whenever we have to do derivative. Now differentiating with respect to x. So differentiation of root x plus 1 with respect to x equals to dt by dx. Derivative of root x is 1 upon 2 root x, and derivative of 1 equals to 0 equals to dt by dx. Therefore 1 upon 2 root x dx equals to dt. Call it as equation 1, call it 2, and call it 3. Now putting 2 and 3 in the equation 1, we have I equals to, now don't write the limits, we have to change the limit because we gone for substitution method. In substitution method, limits are changing. So here in place of root x plus 1, you can write t, so it is a t square, and 1 upon 2 root x dx gone. In that place, what is there? T will come, dt will come. So now we'll do the here integration, but before doing the integration, we have to decide the limits. So how to decide the limits here? Here we are having here x, we are having the x and t value, and here we are having root x plus 1 equals to t, we are having x equals to 4, and we are having x equals to 9. So here t, when x equals to 4, t nothing but root 4 plus 1, so t equals to 3. Similarly, t equals to root 9 plus 1. Therefore, t equals to 3 plus 1 equals to 4. Therefore, new limits are 3 to 4. So write down 3 here and 4 here. After that, we have to do integration. To do the integration here, integration of 3 to 4 t square with respect to t. Integration of t square nothing but t raised to 3 upon 3, and here the limits 3 to 4. In episode number 1, I already explained you how to manage the limits. If you are not getting here how to manage the limits, then please visit again, watch again the episode 1. Now applying the limit 1 upon 3 outside, here is the t cube and the limits are 3 to 4. This is equals to 1 upon 3, here is a 4 cube minus 3 cube, upper limit minus lower limit. So 1 upon 3, here is a 64 minus 27. So 1 upon 3, here is a 7 and here is a 3. So 37. So that is equals to 37 upon 3 is required solution. Evaluate integration 0 to pi by 2 cos x into 1 plus sin x whole square with respect to x. Solution. Here the derivative of sin x is cos x. Therefore, I am putting 1 plus sin x equals to t. Now differentiating with respect to x. So differentiation of 1 plus sin x with respect to x equals to dt by dx. Derivative of 1 is 0. Derivative of sin x is cos x equals to dt by dx. Therefore, cos x dx equals to dt. Step 1 is over. Now we will make step 2 to change the limits. In earlier problem, I had changed the limit in the third step. Here, little improvement. I am changing the limits in the second step itself. There you are not knowing if we need to change the limit. Therefore, I did it in the third step. Now you came to know that in substitution method, limits has to be changed. So you can change the limits in the step 2. So we are having here x, here we are having t. And t equals to 1 plus sin x. And we are having x equals to 0. And we are having x equals to pi by 2. So t equals to 1 plus sin 0. Sin 0 is 0, therefore t equals to 1. And t equals to 1 plus sin pi by 2. Sin pi by 2 is 1, so 1 plus 1. Therefore t equals to 2. Now we have changed the limits. In the third step, I equals to, in place of 0, you have to write 1. In place of pi by 2, you have to write down 2. And cos x dx replaced by dt. And 1 plus sin x equals to t, so it is a t square. So integration 1 to 2 t square with respect to t. So integration of t square is nothing but t cube by 3. And we write down the limits here 1 to 2. So 1 upon 3 outside and t cube and limits are 1 to 2. This is equals to 1 by 3. Now upper limit minus lower limit 2 cube minus 1 cube. So that is equals to 1 by 3. 8 minus 1. So that equals to 7 by 3. This is required solution. Example 4. Evaluate integration 1 to 4 cos of log x upon x with respect to x. Solution. Let log x equals to t, because derivative of log x is 1 upon x. So log x equals to t. Differentiating with respect to x, derivative of log x with respect to x equals to dt by dx. So 1 upon x with respect to x equals to dt. Call it 1, 2 and 3. Now we have to change the limits. So here is the x, here is the t, and t equals to log x. Little improvement in the step. Now x equals to 1 and x equals to 1 and x equals to 4. So t equals to log 1 to the base e, that is t equals to 0, and t equals to log 4 to the base e. Step 2 is also over. Now we have I equals to integration. In place of 1 and 4, we write down 0 and log 4 to the base e. Here is the cos. In place of log x, write down t, and 1 upon x dx equals to dt. Now integration of cos t nothing but sin t, and here is the box, here is the lower limit, and here is the upper limit. So that is sin of log 4 to the base e minus sin of 0. So the final answer is sin of log 4. If you do not write e, then it is understood it is natural logarithm, and this is required solution. Example 5. Integration 1 to root 3 under root of tan inverse x upon 1 plus x square with respect to x. We know that derivative of tan inverse x equals to 1 upon 1 plus x square. Therefore, let tan inverse x equals to t differentiating with respect to x. So differentiation of tan inverse x with respect to x equals to dt by dx, that is 1 upon 1 plus x square with respect to x equals to dt. Call it 1, call it 2, call it 3. After that, we have to get the new limits, and here is x and here is a t, and t equals to tan inverse x. Here is a x equals to 1 and x equals to root 3. So tan inverse 1, that is t equals to tan inverse 1, that is equals to pi by 4, and here is t equals to tan inverse of root 3, so that is t equals to pi by 6, sorry, pi by 3. Now after getting the new values, now I equals to, in place of 1 we'll write pi by 4, in place of root 3 we can write pi by 3, and here is a tan inverse, that is root t, and 1 upon 1 plus x square dx, that is replaced by dt. So this is equals to pi by 4 to pi by 3 t raised to 1 by 2 with respect to t. So I equals to integration of t raised to 1 by 2 nothing but 1 by 2 plus 1 upon 1 by 2 plus 1. Here is a box, and here is a pi by 4 and pi by 3. So that is t raised to 3 upon 2 divided by 3 upon 2, and here is pi by 4 and pi by 3. Therefore I equals to 2 by 3 taken outside, and t raised to 3 by 2 and pi by 3, and here is a pi by 4. that is equals to 2 by 3, upper limit minus lower limit, 5 by 3 raised to 3 upon 2 minus 5 upon 4 raised to 3 upon 2. So this is required final answer. Example 6. Evaluate integration 0 to pi by 2 sin x into cos x upon 1 plus sin raised to 4x with respect to x. Here I equals to 0 to pi by 2. Direct substitution not possible. A little change required in denominator, that is sin raised to 4 can be written as sin square x whole square x with respect to x. Now derivative of sin square x will give us 2 sin x and cos x. So let sin square x equals to t, differentiating with respect to x. So differentiation of sin square x with respect to x equals to dt by dx. So derivative of sin square x nothing but 2 sin x, and derivative of sin x is cos x equals to dt by dx. Therefore 2 sin x into cos x with respect to x equals to dt. Call it 1, call it 2, and call it 3. Now we have to change the limit. Here is a x limit and here are the t limit. T nothing but sin square x. So x limits are 0 and pi by 2. So here sin square 0 equals to 0. Here sin square pi by 2, that is 1 square equals to 1. Therefore the new limits are 0 to 1, I equals to 0 to 1, and 1 upon 1 plus t square with respect to t, because 2 sin x dx, 2 sin x cos x dx equals to dt, and sin square equals to t, so it has been converted to t. Now 1 upon 1 plus t square, that is integration of 1 upon 1 plus t square. We know that integration of 1 upon 1 plus x square with respect to x equals to tan inverse x. Therefore it becomes tan inverse t, and here the limits are 0 to 1. Now applying limits, so that is equals to tan inverse 1 minus tan inverse 0. Tan inverse 1 nothing but pi by 4. Tan inverse 0 is 0. Therefore pi by 4 is the final answer. Evaluate integration 0 to pi by 4 sec raised to 4x with respect to x. Sec raised to 4 can be written as sec square x into sec square x. Now there are the 2 sec square x, and 1 sec square x can be written as 1 plus tan square x, because from trigonometry sec square x equals to 1 plus tan square x. So here we do write 1 plus tan square x. Now we put tan x equals to t, and derivative of tan x is nothing but sec square x dx equals to dt. Now old limits are 0 and pi by 4. Now tan 0 equals to 0, tan pi by 4 equals to 1. So new limits are 0 to 1, 1 plus t square with respect to t. Integration of 1 is t, and integration of t square is t cube by 3. Applying upper limit and lower limit, we get 4 upon 3. This is final answer. So after going through this video, one thing is clear, that definite integration by substitution method is quite easy. We have to be careful only while changing the limits. Once you change the limits, the problem gets converted into quite easy. It becomes a simple integration. How do you find this video? Let me know through your comments. Meet you again with another topic. Till then, wish you good luck, all the best. Before saying goodbye to you, I would like to request you like, share and subscribe the channel. Bye bye. See you. Meet you again.